In this video, we're going to introduce a topic that's important to bond analysis called duration. And if you're watching this video, you may want to download the template that I'm using here. It's got some formulas and some examples that we walk through that it might be nice to have on a printout instead of just a video. If you want that, I've got it up on a PDF file in Google Docs, and this is the link to it. We're going to start with three basic bond interest rate relationships that you probably learned when you first started talking about bonds. And the first of those relationships is the inverse relationship between market rates of interest and bond prices. Simply stated, bond prices go up when interest rates go down, and bond prices go down when interest rates go up. Because when you're buying a bond, you're buying a fixed cash flow stream. So as market rates of interest go up, the present value of that cash flow stream goes down. As market interest rates go down, the present value of that cash flow stream goes up. So one of the fundamental concepts of bonds is that they're going to move in the opposite rate of interest rates. You want to hold bonds in a declining interest rate environment. Bonds are less attractive in a rising interest rate environment. Now, it's more than just the inverse relationship. There's two other important concepts. One, all else equal, long-term bonds are more sensitive to interest rate changes than short-term bonds. So a 20-year bond is going to go up more when interest rates drop. It's going to go down more when interest rates increase than maybe, say, a 5-year bond. Our third relationship, all else equal, low coupon bonds are more sensitive to interest rate changes than high coupon bonds. So if you're holding a zero coupon bond, that's going to be the most sensitive to interest rate changes. On the other hand, if you're holding a high coupon bond, say 9, 10, 11% coupon rate, it's not going to be as sensitive to interest rate changes. Now, notice in our statements here, we say all else equal. It's a classic professor speak that doesn't always hold up in various scenarios. For example, let's say we're looking at a 20-year 9% coupon bond and a 10-year 3% coupon bond. Now, we said that all else equal, a long-term bond is going to be more sensitive, which would mean the 20-year bond will be more sensitive to interest rate changes. We also said that low coupon bonds are more sensitive. So is the longer time going to be a big factor, or is the lower coupon going to be the driving factor? How do we know which of these bonds is going to be more sensitive to interest rate changes? And the answer to that is the topic of our video today, duration. Instead of focusing on interest or the coupon rate as one item and the time to maturity as a second item, we can just say whichever bond has the longer duration is going to be more sensitive to interest rate changes, and duration will take into account the time to maturity as well as the coupon rate for the bond. Now, another issue with duration that's sometimes important is when we think of bonds and interest rate changes, typically we're referring to this price risk. Price risk refers to the idea, as we stated earlier, that bond prices are inversely related to the market rates of interest. As interest rates go up, bond prices come down. However, if you're going to hold your bond until maturity, you might be more concerned with the reinvestment rate risk. Remember, if interest rates go up, you're going to receive a coupon payment every 6 months or every year, depending on if the bond's semi-annual or annual coupon, and you might decide to reinvest that coupon payment. Instead of going out and spending it, you might reinvest it for a longer term, and if interest rates have gone up, you'll be able to earn a higher rate of return on that investment. So when we look at interest rate changes, there's actually two separate things going on here, price risk and reinvestment risk. Let's look at an example the 10-year 10% coupon bond. Now if I hold that bond for just 1 year, then price risk is going to be more relevant to me. If I only hold this bond for 1 year, I'm not going to have very much time to reinvest my coupons, so I'm not really going to care much what happens to the reinvestment rate. But when I sell that bond, it's still going to have 9 years remaining until maturity, so I'm going to have quite a bit of price risk. On the other hand, what if I hold that same bond for 9 years? If I hold that bond for 9 years, now when I sell it, there's only 1 year left to maturity. It's a short-term bond, so it's not going to be very sensitive to what happened to interest rates. But I'm going to have had several years to reinvest those coupon payments, so the reinvestment rate risk will be more important to me. So if I'm looking at a short holding period, then I need to focus more on price risk. On the other hand, if I'm looking at a longer holding period, then reinvestment rate risk becomes more relevant. Now another question to think about, or another issue to think about, is these two risks move in the opposite direction. If interest rates go up, that hurts me from a price risk perspective. It helps me from a reinvestment risk perspective. If interest rates go down, that helps me from a price risk perspective and hurts me from a reinvestment rate risk perspective. So to some extent, these risks are going to offset one another. If I hold the bond for just the right amount of time, price risk and reinvestment risk will be equally important, and because they move in opposite directions, they'll kind of cancel each other out. So it won't be as critical to me what happens to interest rate changes. This is a way to reduce the interest rate risk associated with holding bonds. And here's where duration comes into play again. Going back to what we said, duration can tell us kind of how sensitive these bonds will be. It also is the holding period where price risk offsets reinvestment rate risk. So duration is two things. One, it helps measure the price sensitivity of a bond, taking into account both the time to maturity and the coupon rate. Second, it gives us the holding period where price risk and reinvestment risk offset one another. So now we want to look at calculating duration. And try not to cringe when you see this next little slide here. Here's our formula for calculating duration. Duration is the sum from 1 t equals 1 to n, where n is the years to maturity. C is the coupon payment, so we need the present value of the coupon payment divided by the bond price times t for each year until maturity, plus the number of years to maturity times the present value of the maturity price, or par value, divided by the bond price. Big messy formula. Let's go ahead and put it into action with an example. We want to find the duration of a 10-year 5% coupon bond when the market rate of interest is 7%. First thing we need to do here is go ahead and calculate the bond price. So if we get a financial calculator and we plug in 10 for n, 7 for our interest rate, 50 for our payment, 1,000 for future value, and then solve for present value, that's going to give us our bond price. And I already did that. The answer for that is $859 and 53 cents. So when you find the value for the bond price, you should come up with $859 and 53 cents. Note we assumed annual coupon payments in this calculation. So once we have the bond price, now we go back. That was one piece of information we needed, the bond price. We also need the coupon payment. Well, if we have a 5% coupon bond, that's going to give us a coupon payment of $50. Market rate of interest is 7%, that's our K. The par value, we always assume par value is $1,000 unless it's otherwise stated. And our N is the 10 years to maturity. So now we have all the pieces of information. And probably the easiest way to do this is with a table. Now, if you want to, probably easiest to set this up in Excel, and then you can very easily have Excel calculate all these values for you, and it'll save you a lot of time. But we start with the first column as the years. So we have years 1 to 10. Notice we have 10 twice down here at the bottom because 10 is our last coupon payment, and then also we receive our maturity value in year 10. So then we have our cash flows. Coupon payments, $50 a year in years 1 through 10. Par value or maturity value gets returned at the end of year 10. Next, we need the present value of the cash flows. Present value of $50 discounted back 1 year at 7% is $46.73. Present value of $50, our second coupon payment, discounted back 2 years at 7%. Remember, 7% was our market rate of interest, is going to give us $43.67. All the way down, and our par value, $1,000, discounted back 10 years at 7%, is going to give us $508.35. If we sum those all up, that's going to give us the present value of all the coupon payments and par value, which, as we know, is the bond price. Same thing we did back here with our 5 key approach. So you can either do it on your financial calculator, or you can just add up the present value of all your cash flows, and that's going to be your bond price as well. Next column we need is the present value divided by the bond price. So the present value of that cash flow divided by the bond price. So 46.73 divided by our $859.53 gives us 0.0544. $43.67 divided by $859.53 gives us 0.0508. So on, all the way down through all years of the bond. Finally, we have our last column, which is the year times the present value of that cash flow as a proportion of the overall bond price. So we take 0.544 or 0.0544 times 1, and I just rounded these off to 3 decimal places here. Year 2, 0.0508 times 0.102. Year 3, 0.0475 times 3 gives us 0.142. Keep going all the way down the list, add them up, and that's how we get our duration. So this 7.935, that's our final answer. That's the duration of this bond, 7.935. And oftentimes you'll hear people refer to duration in years, 7.935 years. Now, if you note, this is a rather long way to calculate duration. If you're doing it with Excel, it's not too bad. Once you set up the template, you can modify for different coupon rates, different market rates of interest, and get your answer very quickly. However, if you're trying to do it by hand, can you imagine how much time it's going to take to work through the duration for a 30-year bond? You're going to have to calculate all those present values, 31 separate present values, get the bond price, take all of those 31 values as a proportion of the bond price, and then again all those 31 times the number of years, sum them up, you're probably looking at a 20 to 30 minute calculation just to come up with duration. So oftentimes I use another approach to calculate duration. This one looks a little bit messier when you look at the formula, but actually it works a little bit easier for longer term bonds. And for this, we start with the coupon payment. We've got a bunch of things dealing with discount rate and the number of years to maturity. So 1 plus the market rate of interest raised to the n plus 1 power minus 1 plus the market rate of interest minus the market rate of interest times the number of years to maturity divided by market rate of interest squared times 1 plus the market rate of interest to the nth power. Add in the maturity value, the $1,000, times the number of years to maturity, 1 plus k to the nth power, divide all that by the bond price. So once we have that formula, again, let's go to our example. And again, I did these calculations ahead of time to save a little bit of time on this video. I strongly encourage you to walk through these calculations on your own, get some practice doing it, and you'll get a better feel for how to apply the formula. But we start out with our coupon payment. Remember, it was a 5% coupon bond that we were looking at. So we had a coupon payment of $50. Our market rate of interest was 7%, so 1 plus 0.07 to the n plus 1 power. So we raise this to the 11th power, minus 1.07, minus 0.07 times n, divided by market rate of interest squared times 1 plus the market rate of interest to the nth power, plus par value times n divided by 1.07 to the 10th power, again 1 plus k to the nth power. Now you might notice over here that's just a present value of the par value, present value of the maturity value, times 10 because we have 10 years to maturity. So that just gives you a little idea of what's going on there. And then this was our bond price, $859.53. Now it's just a matter of working through the calculations. So when I go through all these calculations, I'm going to come up with 2.105 minus 1.07 minus 0.7 divided by 0.00964. Multiply that by 50. Here I've got my 1,000 times 10 divided by 1.07 to the 10th power divided by the bond price. Again, keep working through the calculations, and ultimately I'll get down to my final answer. Duration is 7.936 years. Now note, that's essentially the same thing we came up with in our previous approach. Our last approach, we said the duration was 7.935 years. Now we've got 7.936 years. It's just a rounding difference. So either way works fine. I like this approach better for longer term bonds. If I have a 2 or 3 year bond, it might be quicker to go through the table approach and work through this way. But if I have a 30-year bond, this is going to take me a few minutes to go through and save me quite a bit of time. So this is the formula that I stress to my students in class that they should use. There's one last way we're going to introduce for calculating duration, and that's referred to as the effective duration. And what this is designed to do is there are some bonds that may have what we call embedded options, a call provision, a put provision, different things like that, maybe a convertibility feature, lots of different things going on. So the formulas might not work. Instead, we might want to just look at how sensitive that bond price is. So what you'll want to do is calculate the bond price if the interest rate falls a little bit, calculate the bond price if the interest rate rises a little bit, and divide by 2 times the original bond price times the change in the interest rate. And this works well if you have more complex calculations for the bond prices, or you can even use estimates of the bond prices just from watching it a couple days and seeing what happens to the bond price as interest rates fluctuate a little bit. In my example, we're going to assume a simple bond. So this approach here we're not really adding much value in this example, but I just want to show you how it works. We want to go back and calculate the effective duration for a 10-year 5% coupon bond, 7% market rate of interest, assuming interest rates change by 75 basis points. So this is our same example as before, but now we're looking at given a certain percentage change in interest rate. 75 basis points is 0.75%. So we're looking at interest rates going from 7% down to 6.25% and 7% going up to 7.75%. That's that 75 basis points is telling us. So our original bond price was $859.53. I calculated the bond price at 6.25%. That was just a 5-key approach. So if you want to look at that, we had 10 as our N, 6.25 as our interest rate. Our present value is what we're solving for. Payment was 50 because it's a 5% coupon bond over here. So 50 payment and $1,000 par value or future value. Solve for the present value, and we got that $909.08. Did the same thing at 7.75%, our interest rate increase. Got $813.37. Our change in interest rate is 0.075. So now we just use the effective duration formula. We want the bond price when the interest rate fell minus the bond price when the interest rate increased. So that's going to be the 909.08 minus 813.37. That's our numerator. And we want to divide by 2 times the original bond price times the change in rate. 2 times the original bond price, $859.53, times the change in rate, which was our 75 basis points, 0.75%, or in decimal format, 0.0075. Let me grab my calculator real quick. $909.08 minus 813.37 gives us a numerator of 95.71, and then 2 times 859.53 times 0.0075 gives us 12.89. 95.71 divided by 12.89 gives us an effective duration of 7.425 years. Now note, that wasn't exactly what we got before. Before we had 7.935 or 7.936, but it gives us a pretty close approximation. Also, there's another factor that leads to that difference. When we calculate duration, and a little bit later on in that other video I'll show you how we do duration to predict bond price changes, we'll make an adjustment to make it modified duration, and that modified duration will be a little bit smaller. So this is effectively closer to the modified duration than the duration we calculated here, which is sometimes referred to as the Macaulay duration. This should give you an introduction to duration. I know this was a rather long video, but there were quite a few calculations. Again, that template, if you want the original template, is available to you. Let me find that at tinyearl.com, Brocker duration, and you can have this template to walk through. Hope that helped you follow a little bit on what duration is and how to calculate it. Thank you.